Hey, everybody. You ever look at a hand sanitizer bottle and try to figure out how much stuff can fill up inside the space here? Oh, what is the measurement of this hand sanitizer? It's wonderful that I'm able to provide myself some hand sanitizer, but how many squirts would I be able to get out of this hand sanitizer? In reality, how much hand sanitizer is in this bottle? Is there any mathematical practices or scenarios to kind of show me how much space or hand sanitizer is filled up in this bottle? Can you show me? Geometry. I want to cover surface area and volume. Just give you guys a brief description of what each entity mean. Surface area is pretty much the perimeter of an object, the outside measurements of an object. And we look at volume. Volume is pretty much when you look at an object, a three-dimensional object, it's pretty much the space that's being filled up inside. Is the measurement of this hand sanitizer, right? So we have a hand sanitizer here. I'm gonna use a ruler to kind of measure the height of this hand sanitizer, and I'm also gonna try to measure the width, okay? All right, so I'll be able to measure it using centimeters. So, first thing I'm trying to identify is what is the height of the hand sanitizer. So if we look at, I'm gonna start from 0, and we was to measure this, the height of this hand sanitizer is about 11 centimeters, okay? All right, and then the width, I'm gonna utilize this ruler once again. Okay, so based on the measurement, this width is about 7 centimeters. Okay, so when you're dealing with geometry and you're dealing with surface area and you're dealing with volume, the main important components that we need to be able to identify is our radius. All right, our radius is half of the width. All right, so in this case here, I have to find a half of this width, which is considered diameter in geometry. So I'm gonna write this out as D is equal to 7 centimeters. All right, and then when we talk about radius, radius is half a diameter. So half of 7 is 3.5. Okay, and when you look at pi, pi is representing pretty much half of a circle. All right, so we're gonna pretty much include pi. And when it says 2 times, it's pretty much saying the two bases, right? The two circles, the two cylinders, the two circles of the cylinder, okay? So, using this information, we're gonna take all this information that we found and plug this back into the formulas to kind of determine our surface area and our volume. But for step 1, I'm gonna focus on just identifying the volume, okay? So in order for us to identify that, so using the found information, and we're looking at volume, because it's important for you to identify the volume before you find your surface area. So we look at the volume of a cylinder, is V is equal to pi r squared times height, all right? So we're gonna have V is equal to pi r squared times the height. But remember, we are combining the cylinder with the hemisphere. Hemisphere is pretty much half of the sphere, but the top portion is considered a hemisphere. The formula for the hemisphere is, well, the original formula for the sphere is 4/3 pi r to the 3rd power. Half of that, you're gonna multiply by half. Half of that is 2/3 pi r cubed, all right? So in this case here, I'm gonna add plus all right, so the reason why I added this portion here is because we're combining the two entities. We have the cylinder and we have the hemisphere. We have to combine the two in order for you to identify the full volume of the hand sanitizer. All right, so with this found information, I'm just gonna plug in values now. So we have V is equal to pi times, remember our radius is 3.5. So it's gonna be 3.5 squared times our height, which is 11 centimeters, plus 2/3 times pi times 3.5 cubed, okay? So with this information here, the only thing that I'm going to focus on is just the radius and the height, and I'm gonna leave pi as is. Okay. And utilize my calculator. In this case, it is important to use a calculator because you have pi and you have square values included. So 3.5 squared times 11 is going to be 134.75 pi. I'm going to leave pi as is, like I mentioned before. And then I'm going to simplify this portion here. We have 2 divided by 3 times 3.5 cubed. Okay? Which turns out to be 28.58. So it's going to be 28.58 pi. Okay? So what you want to do here with this found information, you're going to combine them two together. So you're going to have 134.75 plus 28.58, which is going to give us 163.33 centimeters cubed. All right, so the reason why I say cube is because we're dealing with volume. When you're dealing with volume, it's in cubic square, all right? And cubic square is representing a three-dimensional shape. So this is considered a three-dimensional shape. This hand sanitizer is a three-dimensional shape. So in order for us to find out, when we find our unit rate, being as though this original, we utilize centimeters to find the measurements of the outside, but when we want to find the volume inside and it's a three-dimensional shape, you're going to put the unit squares, unit value as centimeters cubed, okay? So this is our answer. I forgot to include pi. All right, so this is our answer. If you choose to simplify it with pi, you can. So I'm going to implement it, simplify it with pi. So we use 163.33 times pi to determine our solution. Our final solution will be 513.12 centimeters cubed. All right, so you want to identify what the answer is. The volume of this whole entire hand sanitizer is 513.12 centimeters cubed, okay? All right, and just to give you guys a heads up what pi represents, when you see pi, pi is equivalent to 3.14 in math, okay? This value here never changes. This is always the value for pi. Now, step 2, we're gonna be able to identify our surface area. So in order for you to find the surface area, you have to find the surface area of the cylinder, and we have to find the surface area of the hemisphere. So we're going to use SA is equivalent to 2 times pi r squared times your h plus 2 pi r squared, right, which is one region. This is for the cylinder. And then now we're going to implement the hemisphere. So we're going to, being as though we combine it, when you hear the word combine, that means to add. So plus 2 times pi r squared. Okay? So the same thing that I did before in the last time, I just substitute the values back into the equation. So in this case here, we're going to have 2 pi times 3.5 squared times 11 plus 2 pi times 3.5 squared plus 2 pi times 3.5 squared. All right, so following the same process as I did before, I'm going to utilize my calculator to kind of simplify these values. So we're going to focus on the values here. So we're going to have 2 times 3.5 squared times 11. We get 269.5 pi. Okay, plus I'm gonna do 2 times 3.5 squared. It becomes 24.5 pi, right? Plus 2 times 3.5 squared. We just identified that over here, so I'm just gonna repeat the values on this side here, which is gonna be 24.5 pi. Okay. I'm gonna simplify all of these values. So we're gonna have 269.5 plus 24.5 plus 24.5, and we get 318.5 pi centimeters cubed. Okay. So now like I did for the first problem. If you want to simplify utilizing pi, you can. You don't have to. All right, so I'm going to simplify using pi. So I'm going to multiply by pi. All right, our answer turns out to be 1,000.59 centimeters cubed. All right, which is a great job, guys.